is the 7th video in the series of video lectures on the chapter motion for class 9. So if you remember our last discussion through video mode was on graphical representation of motion. How can we represent motion through graphs? If you remember that, there we discussed distance time graph in case of uniform motion. If you recall, we were discussing distance time graph in case of uniform motion as well as non-uniform motion. Okay, and we ended up by saying that in the next discussion we will go to a new type of graph or a new graph named velocity time graph. So you can see here, today we will discuss velocity time graph. So as the name suggests, velocity and time. Can you say which one will be the independent variable here? Independent variable will be time and dependent variable will be velocity. So in this velocity time graph, what we will do, we will put velocity on the y-axis and time on the x-axis. So velocity is on y-axis and time is on the x-axis. Now the question is, what will be the type of graph if we consider uniform motion? What will be the type of graph if we consider uniform motion? The word is uniform motion. What is uniform motion? Motion is said to be uniform when velocity is constant. Remember, when velocity is constant, that kind of motion is said to be uniform motion. And constant means it will not change with time. It will remain same with time. So, if this is the graph, whatever be the time, if this graph is for suppose uniform motion, if this graph is for uniform motion, then whatever be the instant of time, velocity is always constant. For each and every value of time on the time axis, the value of v, whatever be the value of v, is always same. That means for this instant of time, this is the velocity, whatever v, suppose v is equal to any magnitude, say 30 meters per second. For t equal to 1 second, it is again 30 meters per second. For t equal to 2 seconds, 3 seconds, 4 seconds, 5, 6, 7, 8, and so on and so forth. Each instant of time, the velocity magnitude is always, or the velocity is always same. So all these points, if you connect, you get a straight line. All these points, if you connect, you get a straight line. So what can you understand from here? In case of uniform motion, that means velocity is constant or acceleration is zero. In case of uniform motion, that means velocity is constant or you can say acceleration is zero. So under that situation, what happens? The velocity time graph is a straight line. This is a straight line. The velocity time graph is a straight line. And is parallel to which axis? Time axis. Okay. So in case of uniform motion, the velocity time graph is a straight line parallel to time axis. You will take this down in your copy. Okay. Now let us go to accelerated motion. This was a case of uniform motion. Now let's see what happens in case of acceleration. In case of acceleration, let us first discuss uniform acceleration. Uniform acceleration. Let's see what happens in case of uniform acceleration. Uniform means a value will remain same, value of acceleration will remain constant, and the value of acceleration will remain constant. That is known as uniform acceleration. Under this situation, the velocity time graph for a body in uniform acceleration is a straight line. Okay, is a straight line like this, or it may be like this. In both the cases, the graphs are straight lines. But here, when t equal to 0, the velocity of the body or the initial velocity is also 0. But in this case, when t equal to 0, the body has some initial velocity. When t equal to 0, the body has some initial velocity, and hence the graph is not starting from the origin. So these two types of graphs. Here, for this graph, you can write initial velocity is 0. Initial velocity is 0, and here initial velocity is non-zero. So these are cases of velocity time graph for uniform acceleration case. Okay, let's go to non-uniform acceleration. For non-uniform acceleration case, let's see how we can draw that for non-uniform acceleration. This is time. So this kind of graphs, you can see here the velocity has increased up to this point. Here the velocity of a body, suppose it is under non-uniform acceleration. That means by what amount velocity will change, you don't know. It's non-uniform. So in such cases, what happens? You may have graphs of this shapes or random shapes graph. Okay. Here you can see the velocity has increased up to this point, then it has decreased again, then it has again increased, then it has decreased again. Okay, so this kind of graphs correspond to velocity time graph for non-uniform acceleration. So in the next video we will discuss equations of motion. Okay, then that is very important. We will discuss equations of motion, and what we will do, we will derive the equation using graphical method. In the meantime, what you will do, there are some activities given in the textbook, some data set are provided. You need to plot the distance time graph or velocity time graph of the given data set and interpret the result. Okay, I hope you will do this and we will check it later. Thank you.